Matcha? Matcha, do you hear me? Can you hear me?
Yes, I can hear you.
This one can also? Okay. So before we start, if you have any question, please let me know. We can try to answer those. I think, can you hear me? Is it on? No? Can you hear me? Good. So let's get started. So today we will finish the last two measures on our discrete statistics, and then we will go on Excel's, trying to tell you how to use Excel to do all the calculations. And hopefully if your laptop with you or your iPad or your smartphone would also do, because we're only doing the Excel spreadsheet. And on Wednesday, we will be doing the lab, where we're doing the R and R Studio. Although in the lab, you also advise, if you want to, bring your own laptop, because you may want to install the software on your computer, but it's optional because the lab has already installed everything there. So if you want to have some idea, then you may want to do that, but otherwise you can just you don't have to bring. Okay, so very briefly that we are going to review what we have learned so far in this class. So just very, very brief. So far, we have learned 3 different measures, right? So the first one is mean, right? Mean is basically exactly the center of data, right? The calculation is sum of observation over n, but the idea is all the observation to the left of the mean, the distance, some of them is same as all the distance to the right. Okay, so that is exactly center by distance. The second is median. It is centered by ranking, but not by distance. So basically, exactly the center of data, right? If you have 3 numbers, the median is exactly middle. If you have 4, then it will be the middle 2. Okay. Mode will be the most frequent measure. So do note that our definition would be even if all the data appear once, we will still call it as a everything is a mode. If everything appear twice, everything is still a mode. Okay. I know about dispersion in the last class, and dispersion, remember, is a measure of actually how accurate is the central tendency, or how spread the data is. Okay, the more spread out, your measure bigger. Right? Basically, remember we learned 5 different measures. Okay, the first one is range. Maybe I just go to the one. The first range, right? Range is the idea that you just basically look at the largest and smallest is how spread the data, right? The pure measure. The interquartile range is you take out the top 25%, bottom 25%, and do the range. Okay, it's a range of a in the middle of data, right? It's quartile is cut into 4 parts. Look at the first cut, the last cut, right? The middle cut is median, but you have to cut into 4 pieces. You need 3 different cuts, right? The middle cut is median. The first cut is first quartile. The last one is the third quartile. The difference between the first and last quartile will be the interquartile range, right? Both of them are measuring this how spread data, right? Again, the larger the spread, the larger those measures. And the last 3 are related to the distance again. Okay, so a variance concept is basically measuring the distance from the mean. Okay, and then you're looking at the square difference, and look at the mean of the square difference, right? That's why you sum up all the square difference over n. Okay, it's a mean of the square difference. And SD will be the square root of the variance. The main idea is because the variance is in square terms, so that's why you take a square root of that. So to make sure that you don't have the problem of a squared coefficient of variation, you divide it by the mean. The benefit is tau, that measures with tau unit, right? Because you have SD is already, say, the measurement cm, then you over the mean with cm again. So the reason why you want to do this is you want to remove the problem of scale and the mean of size. Then you can compare, say, 2 data sets. What is data set 1 and data set 2? Which one has more spread, right? Because the variance get bigger if you have bigger mean, right? So that's why you divide by the mean. Then you just normalize it. Okay. And I'm not going to the formula, but just to remind you, the last style we have is so-called the shaped, which we mentioned that 2 different kind of measure. The first one is kurtosis. It's asking whether the data is symmetric. Okay, if the data if there are a lot of some extreme data above the mean, then we will call it positive skew or right skew, right? There's somewhat a lot of data that is far below from the mean, then will be left skew. Okay, do note that, remember the mean, the left hand side, the sum of the distance will be the same as the right hand side sum of distance, right? So skew means that there are data that actually very far away. Okay, of course that means some data are close by the mean. Okay, and because those far away will be multiplied by 3 times by itself, so these are number big. Okay, do remember the left hand side and the right hand side are the same distance, some of them, but it means that there are more data that are further away compared to those closer away compared to the left hand side. Okay, so that's why it means the skill, right? And the kurtosis, okay? Kurtosis will be actually same, the formula very similar, right? Instead of raised to power 3, raised to power 4, right? And the idea is saying that raised to the power 4 means that the data that are very further away from the mean will be expand, like the number will become very crazy, right? Say suppose, right, 1 to the power 4 is 1, right? But 10 to the power 4 is 1,000, right? So suppose you're one distance from the mean, then will be nothing. But if you're 4 times on the mean, then you will be very large. Okay, so that's why kurtosis is measuring the tail. We want to know whether it's a fat tail or thin tail. If for finance application, that would be very important. But for skillness, it's also very important because you want to see, because a lot of underlying, we have some idea about underlying structure, right? Then you have to see whether the skillness is fitting our idea, and also want to measure those things, right? Is that okay before we continue our journey to correlation and covariance? Is that okay? Any question, query? I mean, we don't need to proceed fast because this is a very relatively small class. So I want to make sure that if you guys are okay, any question? No? Is that okay for those who are in the top of the hill? Is that okay? On this side of the top? Good. Okay. So now, I hope you're happy. Now we are going to talk about this covariance and correlation. Okay. This time is proceed a little bit slower because this is last time we introduced. But what we have so far, before that we have mean, those kind of thing, or talking about each subject, we have one observation, right? You ask the income of a guy, right? We don't care about other thing, okay? Just income, and we cover the mean, variance, and standard deviation, right? But you also look at the data. If you look at the census data or the income data from Labor Department, or look at all other things, we usually, for one individual or one firm or one subject, we always have more than one measurement, right? For example, look at the income, look at the data. We divide, say, people from different education background, right? People from primary school, people from secondary school, people from college, people with postgraduate degree, right? We also have people from different gender, right? So we have two for single individual. We have two set of observation, right? Just remember example, right? We want to look at how your income is related to your education, right? So that's why you guys sit here instead of going to a fund, right? Because I think some more education usually tend to increase your salary. Okay, of course, you may like studying or you may not, but regardless of that, we know that in general, we see that having one more education actually help you to have one more salary. Okay, so correlation is try to see if this observation is right. Okay, but do you know that correlation or covariance, this kind of measure doesn't imply any causal relationship, just telling you that they move together up or down. Okay, it may be just that high income people tend to educate more. Okay, there may be something hidden, right? Because they have a better intelligent quotient, and more smart people maybe enjoy studying, less smart people maybe enjoy less studying. Okay, and at the end, they also, smart people tend to maybe earn more. Okay, so we don't know whether there may be genetic factor that affect a lot. So we didn't prove it in this way. Okay, we just show that they're related. So this is very important. That distinguish business statistics and the statistics in science. Right? In science, you don't need to worry about that, right? Because science, you are in the lab, you're in a control experiment, you know what you change. You only change one thing, and then you see the outcome. So the causal dimension is not a big issue in the experiment, right? For business application, or for social science application, then causal relationship can be a little bit trickier. Okay, because you don't, there may be something in the background you don't know. Okay, but anyway, just a caveat, but you will learn more if you go to study in other class. They will tell you, because basically all the advanced class, at least in economics, most of them are trying to see how to establish the causal relationship, right? For example, one of the most debated question in also education is saying that is going to better school is good for you, right? And it need not be, because they're what we call selection bias, right? Those who go to better school, actually they're better student, most likely, right? So it's not clear that whether there's a value add in going to better school, or is there a value add into a smaller classes. Okay, so there's a lot of issue over there. But I mean, for a moment, we don't need to worry too much. But let's consider what the covariance and variance, covariance and correlation coefficient they are. As you can see, the name covariance, you will expect the formula actually is similar to variance. Okay, indeed it is. Okay, so let's consider our data. Instead of x1, x2, x3, right, it will be income of guy number 1, income of guy number 2, income of guy number 3. But now instead of income, we have education. Okay, guy number 1. Okay, x1 will be guy number 1's income and guy number 1 education. Okay, and x2, y2 will be the guy number 1 income, education, so on and so forth, and data. So you can see a pair observation here. Pair observation means that is you cannot break it down. Okay, it's a pair already, so it must be a same guy. You observe two things. Okay, and now the formula. If you see if y1 and x1 are the same, or y2 is the same, then this becomes a square. It's exactly the variance idea, right? Exactly variance, right? The sum of square this thing. So what is this formula is telling us? Because you want to see if the income and education are going hand by hand. Okay, what do you mean by they go hand by hand? They move together. Okay, with respect to what? Okay, with respect to their own mean. Okay, it means that if income is above the mean, your education is above the mean. Okay, so to repeat, what it means is if you are more educated than your peers, you should earn more than your peer. Okay, if you receive education less than your peer, you'll be having less than your peer. Okay, then they are positively related. Okay, that's what I mean. Okay, both above the mean at the same time, both below the mean at the same time. Okay, so that is what the formula is. If x is above its mean and y is above its mean, this is a positive number. Positive number multiplied together will be a positive number. Okay, if they are both below mean, this is negative. Negative become positive. This is positive. And if they are always above the mean together, below the mean together, this whole sum is positive. Okay, but what happens if the other way around? Okay, what happens if in a some of the world where you're more educated, you earn less? Okay, don't laugh. It is possible. It happened in history in many places in the world also. Okay, so how do you look at this? Is one is above mean or below mean, then you will see if x above mean, then this positive, y below mean is negative. All right, positive negative will be negative. Other way around, you will be negative positive will be negative. Okay, if they move in different direction, then that will be a negative. So just recall this diagram we have drawn. Hopefully people here still can see. So this is x, this is y. Okay, and if my data is in this way, each cross means it's a scatter plot, is data. Okay. And you can see if you average all the x is somewhere here, the mean. Right? Lower as x, right? Because all the number here, x dimension, and somewhat y dimension is here. Okay. So in this example, you can see if you try to draw a line that fit this curve, right? You'll be somewhere like this. Okay. And you can see this slope is positive related, but process slope. And this we call the positive associate. Okay. And indeed, how to draw this line properly will be the goal of the last topic of class, to call regression. Basically, it's just try to draw the line that best fit the curve. Okay, and that is actually the goal of our whole course. But we just learn a little bit first. What is they're positive related, right? Because this when this point, right? This is above the mean for x, and this is above the mean for y. So multiplication give you a positive number, right? And here, this is below the mean, so this minus this will be negative, and this minus yi will be negative. Okay, so this is positive number. Okay, and consider alternative scenario. You have here, the data is here, all this. Okay, and then you draw the line. I use a dash line. You'll be here, right? Okay, so this will be negative slope. Okay, so this covariance measure is giving you only the sign will be the most meaningful thing. Of course, the bigger the number, then they're more possibly strongly related. Okay, and here we have the sample counterpart is dy n-1, same as variance, and we don't explain why that's the case, but that is the formula here. Is that okay? So lastly, we talk about the final measure is called correlation coefficient. Okay, so what actually is doing is you have the measure we have is sigma xy. Okay, but now you divide it by the SD of the two, standard deviation of x, standard deviation of y. Okay, why we want to do this complicated dy n, dy by n, dy n, but that is the formula. But why you want to come up with this crazy formula is because after this formula, what you get is always between -1 to 1. How to prove it? Just a standard Cauchy-Schwarz inequality. But we don't care about math here. So just if you want to know, then it's just basically Cauchy-Schwarz inequality. But this must be between -1 and 1. Okay, that means in particular, when you have 1, let's say a picture, then will be give you some idea. When it's 1, then it's exactly the straight line, positive slope. If -1, will be exactly the line there. Okay, if like somewhat positive above 0 but below 1, will be like this. Okay, it's a good line there, but they're not exactly fitting. But that will positive be 1. It'll be bigger than 0 but less than 1. But it's look like this. Will be negative, but it's not really perfect, right? And you may ask what is 0? 0 is something like 0 will be something like actually look like this. Either you include all the cross, and if you include all the cross and the circle in the graph, because you cannot easily draw it. Basically, just like what do you mean? 0 means there's a flat. Okay, means that x and y are not related. Okay, what it means is telling you any x doesn't actually helping you to say anything about y. X and y are not related, right? Either you can draw this or can draw that. It doesn't mean that. It means you cannot really fit anything good. Okay. So that is the you may ask, I don't have sample counterpart here. The reason is the sample counterpart is the same thing. The reason is it's like this. If you replace everything by sample, you over n minus 1 n minus n, same as u over n, right, because they all cancel out. So same as the original one. So that's why it's very funny for correlation coefficient. The sample counterpart is same as the one you want to measure. Okay, just as a mean, you don't have to over n minus 1, right? That's the mean. Okay, it's something very interesting thing. Okay, the proof is here, but I guess no one cares about the proof. But that's simple. It's okay. Okay, just remind you what we're doing here. We have the first measurement is covariance, which you can see is the same as variance if x and y are the same thing. Okay, but if with two different type of observation, then this formula tells us how x and y move together. If positive, they move together in the same direction, above the mean or below the mean. Okay, they're friends if they're positive. Okay, if they're enemy, they're negative, right? I go north, you go south, right? You go east, I go west. Okay, just you above the mean, I below, you below, above. Okay, and this is not easy to compare, right? So that's why you want to make it to a nice measurement. Is within -1 to 1, right? Then you will be very easy to compare. So that's why how you make this adjustment is to divide them by their standard deviation, and by magic, okay, turn out to be -1 and 1, and their meaning for -1 all lie on the same line negatively from your direction, I guess this one. Okay, and if they are +1, they will be like this, right? Everything is lie on that line. Okay, if like slightly positive, it's between 0 and 1, will be somewhat here. Okay, negative is somewhat there. And you may ask what we call strong. Usually, as a rule of thumb, you will say more than 0.6, then you will say something strong. Say if more than 0.6, then you say have a good correlation between them. Okay. If like 0.4, 0.3, 0.2, then probably you would just discard it. You don't really care too much. Okay, but this rule of thumb, but usually you only have meaning to say when this correlation is like 0.8 or 0.9 or 0.7, then you have something to say. If like just 0.4, 0.5, then probably you would not make a big meaning out of it. There's something, but it's something not very strong. Okay, of course, it's 0.9, then you can say a lot of stuff. But that's very important. I mean, of course, those people who are here from finance, then probably you would. This covariance and correlation coefficient is very important. Okay, this is the idea of what we call the diversification. Okay, the reason why people want to invest in Bitcoin these days is Bitcoin, one of them, is unrelated to what happened in the real economy. Right, that's why the gold is also unrelated too. So you want to invest, and you invest something is not correlated, then it's good, right? And that is actually related to what we learn finance, the beta, right? Is how your undiversified risk, right? Those kind of things. Because this is how you get, actually it's how you get beta. You draw a line there, right? So basically it's how you get the beta, right? Is you would try to get is return of you calculate the stock price, right? The return for each stock, right? RI, stock I, and you have the return of the market, the Hang Seng Index. Say suppose Hang Seng Index is on the x-axis. This axis is the stock of whatever you like, okay? Hang Seng, maybe Tencent or HSBC, right? And then you ask, what's the pair observation here? Each day, you can see the price movement, or what we call return, right, of at one stock, right? Then you will be having a dot here, all right? This dot represent, this is today's return of the Hang Seng Index. Is a return for, say, HSBC, right? How to calculate return? You know how to calculate return, right? Is today's opening price. I mean, it's today closing minus today opening and today opening, right? Or this is open to close, but if you want to see, can be close of today minus close of yesterday over close. I mean, there are a lot, but it's not finance class, okay? I'm not going to teach the finance, okay? Although I teach in finance Singapore, but anyway. But you have this kind of dot, right? And then you have, right? Many days, run the line, then you get the beta. Right? But anyway, it's not. But usually you can see if they're positively related, right? They move together. If they move negatively, right? But stock is like this, right? But sometimes you want to invest in something outside, say, the US and Hong Kong, right? That's why you invest in the emerging market, right? That's why they're negative related, then you reduce the risk, right? But anyway, it's not the class of finance, but that's how to show you why you care about the relationship between stuff, right? Because basically finance is trying to look for things that are negatively correlated, right? Because you want to reduce the risk, right? Because you combine excess with different negative correlation, that's good for you, right? Because if this move up, the other go down, they combine them in same portfolio, then the portfolio return will not fluctuate that much because most of people hate risk, right? Because we like some certain thing. So when you combine different investment with negative correlation, right? That's a good thing. So that's why we care about those. Okay. And also same for insurance company, right? You want to combine different subject with different correlation, right? If insurance company try to insure everything in the same region, then usually I mean that would be very risky because you cannot pool the risk because then when flooding goes out, then the insurance company will get broke. But anyway, I guess it should be okay now. Any question before I go to Excel? I hope I give you some idea why we care about correlation. If no, any question, then we can go to Excel. So please try to have Excel ready. Before that, I mean, this example is very quick. This is a quickly good example. X and Y, you calculate difference, and your product of them, calculate the square of those, right? And don't worry, we will doing this in Excel very soon. But this is data, right? Subtract the mean, and you can calculate the sum. Okay, sum of all this, sum of all this here, sum of all this is here. Okay, and you can calculate the population variance, sample variance of X and Y, right? And oh, I guess this would be Y. Sorry, typo here. And covariance, right, will be just over the number of them, right? And SXY divided by n-1, okay? And same correlation coefficient, you can either do sum of these over square root of product of that, okay? Or you can take the covariance over the 2SD, okay? This population version, this is the sample version, all give you the same result, okay? So don't worry. Is there any question for this one? That's basically straightforward. So don't worry, we will create this in your Excel. But before we go, I mean, any question about that one? Is there any question? Top of the hill, okay? Is that okay? Good. So let's go to Excel because I guess it's too boring to continue. So these are the video links. If you confused, you can go to watch the video. But I guess most of you know what's going on there, so I don't think you need it. Okay. Go to Excel. Excel, what we have is try to use the calculator. So, oh, now it's not that easy. Let me share the screen. No, this is not very good, Excel. Okay. So this Excel, I guess everyone have what I have here. You can use Google Sheet. Usually should be fine most of the time. or they're basically there's compatibility between them. Okay, and so I guess I can start. Okay, so here the important thing is to make our life easier. The right bottom side, just zoom a little bit. Make sure our eye don't shrink too much. Okay, now very simple. I assume you have absolutely no knowledge about Excel. Okay, just I start from basic. But if you think I'm too slow, let me know. I'm too fast. Okay, because teaching programming is somewhat depends on the audience. Okay, so there are two ways to do it. Okay, now you can see this a spreadsheet, so we do all the calculation here. Okay, so the good thing about Excel is everything is very direct, but the bad thing is everything is hidden, the formula. So later you will see this is a pros and cons here. But anyway, let's get started how to do the calculation. Either double click the first cell, or you can click here and click on the formula bar. Okay, the double click here or there. Okay, so so I usually do it here because it's more easier. Okay, so the easiest thing to do is to use a calculator. This is how you start with any computing software, to take it as calculator. And when you use the calculation, you always have start with equal. Okay, equal. For example, the simplest is 1 plus 2, then get you 3. Okay, so that's the first thing. You can say is 1 minus 3. Okay, is 2. Okay, so now I want to. Then you also want to do the maybe. In the meantime, I just don't worry about this one, but this is how the formula on the left hand side. Okay, and then you can do is equal to 3 times 6. Okay, and this all multiplication, division, raised to the power is basically what we need. Okay, so you can try to type in here. You should be able to get all this. Okay, and this is raised to the power. So it's important. So let's try to raise the power, because basically all this is the formula we need for our class, mainly for basic calculation. But so it's equal to 5 raised to the power. Raised to the power, if you use a PC, then it will be shift 6. Okay, I know it's very trivial, but I just want to make sure we left no one behind. Is that okay? I know it's too trivial, but let me know if there's any problem, because who knows, you may have questions. Okay, okay. I know it's very simple, but we soon getting more interesting. Okay, bear with me. Okay, any question? You have question? No. Good. So now we have how to calculate, and next is the two formula. Take square root, and we know what the square, but take square root would be SQRT, or take square root, you can use the head sign, head to the raised to the power 0.5. But SQRT will be the easiest. And exponential, this one we use it when we calculate the Poisson probability later. So this means the e to the power x, and e is 2.713, if you remember correctly, something like that, 2 point something. So let's show you the example, because I guess this is something that probably you might not have seen it before. Let's do quickly. So if I want to take a square root, it's SQRT is 4. Okay, so this is giving you the 2. Okay, one thing I want to remind you, this is something so common. If you happen to know B.B.A, I don't know, I probably don't have time. I don't know we have time for this class, but usually I teach B.B.A, then you notice that SQRT is used in Excel, but if you use B.B.A, then use SQR, don't have the T, so very confusing. But anyway, and we have EXP is not experience point, but it's raised to the power, so it's Summary is EXP5. Okay, so we will need that when later when we do Poisson, but not this class, but will be the third topic. Okay, we'll do exponential. Okay. Okay. Is that okay? Now, very trivial still. Now we are trying to do the data. Okay. And to do the data, we have to, the first thing is count of them. This is data, right? And then we want to add, right? The division of these two will give you mean. Okay. So that's we start to put data mean. Okay. And for Excel, you may see that to input the data, okay, actually that you would have to put a bracket there. Okay, if you want one formula there, okay, you put a count and put a bracket, then this, okay, and this is you can see the capital letter, which is same as the EXP, and also the square is what we call Excel built-in function, which is created by the Excel. Okay, and if you want to have your own, then you have to what we call, as I said, called B.B.A. But I don't think we have time to teach this because we are spending time on R, and R is easier to write those stuff. So we just rely on what is given by Microsoft Excel. Okay. So this count number of them is just 5. This sum is some number of them. Okay. But let me try to work it out. Okay. So if I have count, okay, and a bracket, and I need to put 1, 2, 3, 4, 5, okay, and a close bracket, that gives you 5. Okay, so that actually count how many of them. Okay, and similarly, if I have sum, okay, and 1, 2, 3, 4, 5, close the curly bracket. I hope you know where curly bracket is. Is above the enter, that's the 2 key there. You need to have a shift and get it. Okay, so this is all the sum. Okay, that's how if you want to have single cell to do all the calculation, that will be fine. Okay, that's how you enable yourself to do the Excel. Is there any question before we proceed to more interesting thing? Okay, now I hope it's okay, right? This one. Now we are going to a little bit more, okay? And here I have a function we call run up and run down because you learned that for calculate your median, okay? And run down is a formula, but I'm not going to do it in Excel. I think this is too trivial, okay? Run down means I just get the integer, right? And run up we will give above, okay? Note that run up 3 will give you still 3. Okay, just to show you. I know it's too trivial, but so if you run down 3.1, so you have to enter number of digits. So for our case is you always run down the integer, just 0. Okay, yeah, write that down there. Yes. Sorry, I should have a comma 0 like what I'm doing here. So here, sorry for the typo, I should have comma 0. Okay. Similarly, if I have run up 3.1 and then 0, which will give you 4. Okay, so that's how you get the run down. Okay, the basic calculation. You can try that. Let me know if you have any question before we proceed. Oh, sorry. Now with that, we can start to calculate, do our statistics, right? So now we know all the calculation. So now we are trying to do it. Okay. Now, before we said we have to do the bracket thing to get the data. Now to get the average, geometric mean, harmonic mean, right? So that's how. Let's get started with that. Okay. Average. And oh, so typo there should be harmonic. Okay. So let's start to the column 2 here, another column, because looks. So we need to calculate the average, right? So it'll be average. Okay. And we put the number, say 1, 2, 3. Let's make it simple. Okay. Then you should get the 2, right? This is the formula. Right? Average 1, 2, 3, right? And then we can do the same. We can do his average. Okay. We can do geometric mean, geomean. Okay. And you get 1, 2, 3. Sorry. 1, 2, 3. Okay. There is. You can see this 1, 2, 3. Surprisingly, right? It's below 2. Okay. It's not bigger than that. Okay. Actually, there is a formula we said is AM is bigger than GM in mathematics, but that is what we have is geometric mean is always below the average mean, and then we also have harmonic mean, right? You can also have mean. You put 1, 2, 3. Okay. So you should get all this relatively easily. Okay. Any question? So for the average. Okay. And now we want to talk about weighted mean, right? The weighted mean is in the Excel, you don't have the weighted mean function. Okay. So what we need to do is what we call the there's a shortcut we call the sum product function. Okay. So let's show you. After this, we have a break. So Excel, no, why it's not? Why? Okay, yes. So what we call is called the sum product function. So what sum product function is? You see this one. Sum product means you take, say, 1, 2, 3, 4, 5. That's the first element. 6, 5, 2, 6, 3, 2, 3, 2 is the second entry. Sum product means I multiply 1 by 6, the product, and you sum is 2 plus 3, okay, and you multiply 3 times 2, and you basically multiply 1 by 1 and add them all up, okay. And this is actually the formula we have, right? Because the formula of the weighted average, right, will be this. Right. So basically it's W1 X1, W2 X2, and W and Xn divided by W1. So that is here I have all the weighting. This is all the X, right? X 1 times 6 plus 2 times 3, so on and so forth. And here's some of them. Okay. Now, I'm not going to demonstrate this on Excel, but you can try. This is how you calculate weighted average. Okay. So this is rather stupid, right? Because I have to type the data in this way. We are not using the spreadsheet, right? Because spreadsheet, the good thing is, also the bad thing is, you put data and the formula at the same time. Okay. After the break, we talk about how to use what we call the address of the cell. When you calculate, you refer to the data into the spreadsheet, then you do calculation. Okay, for the moment, let's take a break. We'll come back at 10:30, and then we'll do more serious Excel. Okay, so far we just give you some flavor of Excel, just familiarize yourself. So that's a break of until we have 10:30. Yeah, break now. I'm here to answer any question you might have. So let me know if you have any question for the people in the Zoom. Wow, you're very powerful. Sorry. Copy first. Oh, I don't know where Okay, you can see the numerator is there. And I divide the denominator. Then I now check why the problem. Yeah, usually you once you do the usually you write the formula. Otherwise, I don't know what you type of. But that's usually you divide things. Sometimes. Next class will be more fun. Excel will be more. And we do R with except we start with learning Excel is a helpful for you to learn so the thing about Excel is very easy to learn how. Direction. I think you know it. Learn something. Oh. I see. We will do our next class. Anu and Matcha, do you have any question? Let me know. You have any question? No, that's good. So 2 more minutes, then we continue our journey. We'll be talking about median. I guess we can start. So median by itself is, remember the formula, is rather complicated, okay? But Excel can help you to handle everything, okay? So you can see if I median this function, I input, if I put 1, 2, 3, 4, 5, gives you 3. I give you 1, 2, 3, 4, 5, 6. Actually, the computer handle it already, okay? Here I put the sort data. I put 1, 2, 3, 4, 5. Actually, you can try. If you put 2, 1, 3, 4, 5, doesn't really matter. They can still give you the right answer. Okay, you don't have to sort the data. Okay, let me show you. Okay, so suppose I have the data here. I do the median. Okay, I do the median. Okay, I'm not going to follow the order. Maybe I have 1, 3, 2, 5, 4, 6. Okay, I don't have to follow the order. And the computer will smartly still give me the required answer 3.5. Okay, it's not 1, 2, 3, 4, 5, but I have of them. Okay, so that means that of course, it means that our life is much easier. Okay, of course, you may ask, why bother to teach you all the formula, right? Just tell you Excel, then you're done, right? The reason we need to know it, right? Because we need to know the underlying idea behind it, right? So that's why we really want to know it. Okay. Now, so far we enter data into the formula, which is super inconvenient, right? You can see. That's why the good thing about Excel is you can put the data and the formula at the same place. So what is it is we need to rely what we call cell reference. Okay. So instead of putting the data into the formula, you separate the data and the formula. Okay. And so there's a relatively complicated idea here is what we call the absolute address and relative address. Okay. So the idea is if you don't do copy and paste, okay, which is the most, I would say, the most powerful one in Excel, there's no difference between you tell a cell A1 with dollar sign or no dollar sign. Okay, so A1 actually means this particular cell. Okay, this A1, and this cell we call B2, and this cell we call C1. Okay, so this we call it by column and the row. Okay, so it's slightly different from mathematics. Usually you have row by column, but in Excel you have a column by row. And let me show you. Put up a new spreadsheet, and I will just zoom a little bit further. Okay, so what is the address here? Okay, so suppose to put a number here 5. Okay, and I have another number here, this 3. Okay, and we really want to figure out the sum of the two, say, right? Then what we're going to do will be just saying equal to. Maybe I make it bigger, so it's still small. So we'll be just say equal to. I want to input 3 plus 5, but to make our life easier, we want to separate data and the calculation, right? So usually what you put is you just tell them I want A1. Okay. Whether type it in or you just click that. Okay. Give A1. Okay. And you add, suppose, A2. Okay. So then once you have this, the computer will know, try to get what is in A1 and what is in A2. Okay. Then your life is easier, right? So that's why what here is this. Okay. And of course, if you do want to make it nicer, you want to have decorate a little bit, right? You want to have a say double border here, right? And then you want some underline here. Okay, that's usually how you make your data and calculation separate. Or one good idea is just try to say color it, right? And you do different coloring. Okay, there's some minor technique that make your life easier. Otherwise, you don't really know what's data, what's calculation, right? Or sometimes you want just put some description. Okay, although all of them here I have all the number, but usually you can put some description, right? Okay, so you can, instead of this, okay, or can put, I can say I do here, this is 3, and I have this plus this one. Okay, and I can say this is the sum here. Okay, and this is data, maybe this x1, this is x2. Okay, then you add another column there, they will be much more nicer. Okay, and usually if you have this thing, you would want to put it on the right hand side, so just some minor detail. Okay, so now the question is, the formula here I impose is C1 plus C2, right? And if I have another column, which I do the same thing, okay, maybe 6 and 7, okay? So do I need to input the formula again? Okay, so the good thing is about Excel is you can do Control-C, Control-V, or copy and paste, or drag. Okay, there are a few different ways to call it. So the easiest way is to pick this one, and actually the copy and paste is so useful. Indeed, you see the first thing on the very left hand corner is a copy board. That's a copy and paste. Okay, if you have a keyboard, it's Control-C and Control-V, copy and paste. If you have the iPad, then it's a little bit more complicated. But if you then Control-C, the shortcut, Control-C, okay, you copy this cell and you can paste it here. Okay, then automatically you can see the formula. Originally C1 plus C2. You copy and paste, all the formula we move one, okay, from column C to column D. Okay, so that's a strong point of Excel. Okay, and the question is, sometimes you want your formula move with your copy and paste, but sometimes you don't. Okay, the reason why some formula there's a parameters, the number that keep constant, right? As opposed to always want to keep 5. Okay. Okay. Maybe I just. Okay. So this is this. Okay. Now suppose I really don't want this. I really want to keep C1 plus maybe C1 plus D2. Say I always want to keep this. How can you do that? Okay. How can I always keep this formula here? So to do so, instead of C1, you put a dollar sign there. Okay, put a dollar sign there. Okay, you put a dollar sign. Okay, and if you move across, then you see move across the same as copy and paste. Maybe I just do again. Use copy and I paste here. Okay, so you can see the formula. Actually, if you have a dollar sign, then nothing changes. Okay, and then you see this have $2 sign, which means that I have dollar sign between C, means that I move column wise, doesn't change. I have dollar sign for 1, which means that I go up and down, the 1 doesn't change. Okay, so to make yourself understand what's going on, I think it's the most important thing in Excel. As for beginner, let's do a very interesting exercise that I always ask people to do it when you want to do it. Is we want to do a multiplication table. Okay, so we want 1, 2, up to 9. Okay, and I do copy and I rotate. Sorry. Okay, I have this 1, 2, 3, 4, 5, 6, and 9. Okay, I want to fill in. I want to fill in this yellow part. Okay, and what is 1 times 1 is 1, right? 1 times 1 is 2, right? And then this entry will be 4. It's the multiplication table you learned in primary school. Okay, all I want you to do is to try to use the idea of relative address or absolute address or whatever to fill in this quickly. Okay, the quickest you can do is within 3 steps. Okay, just type 1 cell and do 2 copying. The fastest, but try to do it. I give you 5 minutes to do it, because I think that's, if you understand this idea, then you know everything. Okay, try to fill in this. Means you fill in this all AT1 cells with what we learned. Okay, give 5 minutes, then we will discuss. So just remind you, the last entry is AT1. So remember, try to use a wise use of relative and absolute address will be helpful. Okay, you know, if you're getting a big number, then you must be doing wrong, because you know this multiplication table. Oh. Doors. Good job. Huh? To give you some hint, let me do the first column. Okay. So this one is you are multiplying. In this case, will be A2, okay, times B1. Okay, maybe I make it bigger because I guess you may not easily see that. Okay, so this is A2 times B1. Okay, and suppose I do the first column. Okay, what I'm going to do the first column when I move down the formula. Okay, everything move down, right? So let's see. Then you will see why you get how you get it right. Okay, so you move down. What happened is the above one also get moved down, right? Which is B2, which we don't want. We want to keep it as B1, right? Okay, so immediate answer if you get $2 sign here. Oh, sorry, you will get $sign B, $sign 1, right? And then you just copy and paste, or you just the easiest way in if you use a PC, then just drag it down. Okay, or you just copy. You just do copy, and then you highlight them all. Okay, then you put paste. And the same thing. Okay, so this is how you get your first column. Okay, actually you can do the same. Okay, for this one, right, will be equal to this A2 multiply C1, right? Remember C1 we want put a $sign here, $2 sign. Okay, and if you do this thing again 9 times, right, you can get this times table. Okay, but as I said, this is still not very smart. Okay, try to figure out what are the more smart way. Okay, this is still not too smart. Okay, because you have to type 9 times and copy and paste 9 times. Okay, there will be a much smarter way. Okay, I'll give you 2 minutes to figure out whether there's a smart way to do it. Okay, there's a smart way to do it. But I double click this one too. Now you have flavor of what I'm doing here, but is that okay? Okay, but try to figure out there's a very smart way to do it. Oh, okay. 就咁拉係嘛？哦，都得。 覺得呢個係 Excel 佢好聰明學咗啫。Okay, so now maybe I can tell you how to do it quickly. Okay, so you can see, you compare this formula here. Okay, so just you want to understand this, you understand the structure of what you're doing. Okay, every single cell actually has the same formula, right? You always multiply this number to that number, right? And what is the feature of this number? You always keep the column the same. Okay, and what is the feature of the second number? You always keep the row the same, right? So that means the formula is like this. The first number, you always keep the column same, so you just put only the dollar sign. Okay, for the second number, you always keep the row same, so you just need this formula. You copy all this, then you're done. Okay, see, you just copy, either you just drag. Okay, you can just drag. I make it smaller, or copy and paste, doesn't really matter. You can just drag this out here, and the shortcut here, double click. Right, that's kind of like I do it, but just drag, and I'm done. Okay, the same formula apply everywhere. Okay, see this example here. Okay, this example, say this formula will be just A3 times C1. Okay, so this is the idea. I hope you get it, because this is very useful when actually working. Okay, so I can say actually all my Excel skill are learning from as an intern for the actuary. Okay, that's how I learn. I spent a few months there, then I basically learned, because you really need to know how all the shortcut. And you can see the professional there, they're so fast. Just don't, they're done. Okay, and they don't use any mouse, basically only keyboard. Then they're done. So if you want to be expert, then Excel will be the good thing. Of course, now I guess it's not that useful because now use more computer. So Excel will not be as useful as before. But for those who are accounting or those in finance, you are not doing heavy calculation, then Excel is still the best way to go. And this is what your manager knows, right? They know how to do Excel. Okay, did I make Excel clear here? Okay, so I hope that this can be help exercise, because I think that you understand what's going on in the Excel. Okay, so here example is I have two data set. You can see I also color it, so that's make your life easier. So try to use more color. Okay, and column 1 data, column 2, and then you can calculate average and median. Okay, I hope that's okay for you. Any question up to here? Okay, now we've just done this exercise. I hope you like it. Now the next thing is I want to show you this minor skills is in Excel is to give names. Go to formula, define name, then will be very useful. Okay, so let me open another sheet. Okay, so where is the thing? Go to the formula tab. Formula tab. There's what we call define name and name manager here. Okay, so when you use it, say a lot of time, calculate a spreadsheet, you will use some global option, say interest rate. It's applied to calculate a lot of things, right? So the interest rate, for example. Okay, or sometimes you say delta, maybe actually the notation for interest rate delta, right? So and that's what you do, or maybe R. So you can put a number here, say 5. Mr. Delta cannot be that, right? So it can be maybe 0.8, okay? Or maybe you put interest rate, maybe 10%, right? 0.01, okay? Then what we're going to do is you can click a define name, okay? Do note that this name has underscore here because they can't accept a space bar. So once you click OK, okay, it means that whenever in the spreadsheet you call interest rate, we refer to this cell, okay? So let me do it slowly again. So suppose I have this cell B1. I want to call it for the whole spreadsheet. I always use this number, okay? And I click define name here, and this will tell me the name. You can use whatever give, or you can make a name. Okay, you can just type your own name. That doesn't really matter. And the scope may be this whole workbook or whole worksheet. Doesn't really matter. Depend on where you want to use it. Okay. If I want to restrict this name to this spreadsheet, I just choose this one. Okay, in that case. Okay. And then if you want to use it for the whole workbook, then you just choose the whole workbook. Okay. So in this case, I just wanted to use here. Okay, interest rate. Okay. And then in this case, maybe I want to calculate the interest rate, right? Then will be this, right? You can do this plus this guy, right? And you can immediately see once you do it, immediately that's already changed to this one. Okay. Then maybe you can raise to the power 2, right? Then you can do, right? So the good thing about this is you do not, when your manager reads it, you don't need your manager to go back to cell D1 to see what it is, right? Give more informative name to the cell. Instead of telling them it's D1, D2, D3, if things appear of time, basically you should use this name. And the name can be confined to, the whole workbook or worksheet, and this is very useful, okay? Because you don't want your spreadsheet D1, A1, C1 then, okay? Maybe you know it when you write it, okay? But after a few weeks, come back, then you would want to die because it's so complicated. So try to, if you can, to use names, okay? Okay, then you start. Is that okay? There's a very minor technical details that I want to share with you because let's define names, okay? Now, then what's the mole, okay? And for our case here, I have only told you the mole, only one of them, only single mole you can calculate, okay? But I can also tell you that you can calculate more than one. But I don't put in the slide because it's a little bit more advanced, but I can show you now. So suppose our data now, I have, say the data is, say 1, 2, 3, 3, 4, okay? For this case, okay? Suppose I want to find the mole here. Maybe this is data, maybe I change it to here, maybe a little bit less tedious. Maybe I just don't go this way. Okay, I found the mole. Okay, this is data. I put the yellow color. Okay, to mole, I just want to do mole single, and I highlight this, right? I make it bigger. Okay, you can see conveniently they will pick me up the 3. Okay, what happened? You have 1, 2, 2, 3, 4. Then let's see what you get. Okay, suppose you have the other one is 1, 2, 2, 3, 3. Okay, suppose another data set. I use another color. Okay, blue one. Then what we do is copy and paste, right? We can do copy here and we can paste here. Okay, then what you see is they will pick up the first one or the smallest one. Okay, but sometimes that's not what you want, right? Because you know actually the 2 mole. How can you do that? Okay, that if you confuse, it's okay because I'm telling you some advanced function is not needed for a purpose, but just tell you what we call is called array function in Excel. Okay, instead of every value is one output is a one cell usually, right? Excel sorry, each single cell have one output. You want to output from multiple cells. Okay, how do you do that? little bit more complicated, but if you can't follow, it's okay. So what I do is you have to highlight two cells first. Okay, and then you start to type formula. Okay, the formula for this will be multiple. Okay, and then you just from E1 to E5. Okay, and then once you're done, not just enter, you have to put shift and enter at the same time. Why it's not? Why? You see? Oh, I see. I need a shift control enter. So let me try again. I almost forgot. So I highlight the two thing. I type mode, and I highlight this for formula, and I shift control enter. Yes. Okay. Just maybe repeat the procedure here, because I know there's two answers here, right? I highlight these two, and I write the formula. The formula is mode and multiple. Mode and multiple. And my data is from E1 up to E5. Okay. You finish enter the data. You have to press shift, control, and enter three of them at the same time. And then you get the answer of 2 and 3. Okay, that's called array function, but it's not required for our class, but just let you know there's something we call array function. It's small. You can see there's a bracket on the upper hand corner. Okay, but just for interest. Okay, but you don't have to follow. I mean, just let you know there's something there, because you may ask why I have a mode single, because if you're multiple mode, you can do that. Okay, and this is very stupid, but later you see when you do R, that's so straightforward. You don't have this complicated thing. But okay, is that fine? Now, what I'm going to do is to tell you how to do other thing, right? So you can see in this case, the mode for everything the same, everything appear once, just not available. Okay. So, but as I said, we don't want this happen. Usually, you want everything is in the mode for our purpose. Same here. Nothing appear twice, then nothing. And you two appear twice, then it's two. It's they're both, you put one. But if you do what I just said, then you can find 1 and 2. Okay. But it's okay, because Excel is something that you don't often use it. If you do real data analysis. Okay. So now I want to talk about max and mean. And because max and mean is going to give us a range. And then we talk about IQR. Okay. How to calculate max and mean is very simple. Max is the maximum, mean and minimum, right? So this, I give you this, but you can do the cell reference, right? Suppose I open another spreadsheet here. Suppose my data is this one, right? Maybe data is 1, 2. I don't need to order, right? 5. I don't care. I just randomly put some number here. Okay. And I want to calculate, this is the data, right? Data is here, yellow one, my data. Now what I want is I want to calculate the max and the mean and cut the range, right? So what's the max? What's the mean? what is the range? Okay. Max is rather simple. We just equal to max bracket. The data is from B1 to B7. So B1 up to B7. You can like by B1, B2, B3, all the comma, but you can just use the colon, okay, to indicate the range of cells. Okay, B1 colon B7 will give the max. Is that okay? Okay. I do the formula test. Okay, in case you miss it. Okay. And similarly, I do the same thing, mean of B1 colon B7. Okay. Okay. If you don't want to type, you can just use your mouse to drag. Also do the same thing. Okay. Right. So that is max and mean. And the range will be just max minus mean. Okay. So this is how you get the answer. Of course, this, you think this simple formula, you can divide into 2 steps, which is usually recommended you do in this way because you know what's step by step. But of course, if you are really expert, okay, which one day you shouldn't be, you should just use max minus mean in the same formula. Okay, you can just do that. You can just do that. Okay, that's how one step. Okay, but I recommend as a beginner, some of you might be expert, but I would recommend you do step by step. Okay, the reason is you know what's going on. Okay, is that okay for this one? Range, we learn. Okay, this is a range. Okay, now we try to learn IQR. Okay, just not maybe just as dispersion. I don't want to create too much spreadsheet. Dispersion. Okay, so we want to have IQR. Okay, for IQR, the good thing is already the Excel has a function we call quantile dot exclude. Why exclude and include we don't really care, but the exclude actually fit what we taught in the class. Okay, this is the exactly formula we learned the method 3. Okay, so quantile data 1 is Q1. Quantile exclude 3 is the 3. Okay, so let's go back to this example. We have Q1, okay, and Q3. Okay, how we do that is quantile exclude this data set. Okay, we put 1. Okay, and this give me the Q1. Okay, and then I do the same quantile exclude the data. I give you 3. This is Q3. Okay, that's simple, right? And immediately you can tell me what's IQR. Okay, I'm not going to do it. What's the formula? Can you tell me? Yeah, but what you input in Excel? Okay, this what you put here. Can you tell me? Yeah, D6 minus D5. Yes. Okay, done. Okay. Relatively easy, right? That's how you calculate the quartile and the range. Is it okay? That's something deep, something simple, right? So that's why what we learned so far, just like click, then you're done, okay? But you understand what this is a formula, right? That's why I told you in the class we do method 3 because that coincides what we learned. Okay, in Excel. Is that okay? Any question? Is that okay? Good. Now we can talk about variance. Is that okay? So variance, we learned there are 2 types. It's called variance P and variance S in Excel. Okay. Or actually, if you put a variance as something standard, but to make okay, variance P will give you the population variance. Okay, you should do this. Okay, actually give you subtract the mean, take a square over n. Okay, if you do the standard thing we need, say variance S. Okay, this will give you the sample one. Okay, so let me show you the exercise, which is then because of time constraint. So let me actually work it out. Why it's not showing that page? Okay, I want to show you use the spreadsheet to calculate the variance without using that, and then we verify it. Okay, so let's do this. The data x is here. Okay, it's x here. It's 1, 2, 3, 4, 5, right? Say, and then you want to x minus x bar. Okay, what I do is that actually have some. We need some good thing to figure out is x bar is the mean, right? The means mean the same. Okay, we use a smart way to do it. You use what we call absolute address. Will be equal to A2 minus mean, average of A2 to A6. Okay, but we really want it to not change over. We drag down, so we need to put absolute address. You put all the dollar sign there. Okay, to shortcut the dollar sign is use F4. You can just put F4. Okay, F4. Okay, then you just drag it down. Okay, is that okay? That's all. Copy and paste. If you don't know, drag it down. Okay, now to calculate variance, right? That's very simple. You want to have x minus x bar and raise to the power 2, right? Okay. So that's what you do is you just this raise to the power 2. That's how we learn, right? And this one, okay? And variance will be sum of these over how many of them, right? So the formula will be the variance P, right, will be sum of all this, right, and divided by say 5. Okay, and variance dot S will be sum of this divided by 4. Okay, in case you don't follow. Okay, so that's why I write it in the way we write in your slides when do a example. I write in mine Excel. This one column by column and column 2 calculation. Okay, is that okay? Any question? So quickly, I do SD. This will be same as actually just compare the formula here. Okay, to make sure this is right, let's compare. What you see in the Excel, what give you if you put variance P and highlight them to give you the same answer. You get variance S and highlight them to give you the same answer. Okay. Now, then I want to show you the other one is SD. Okay, STDEV, standard deviation. Okay, again we have P and S. Okay, If you put P, okay, SD, P, and SD, S, okay, there will be STD, EV, P, this equation that gives you the population distribution, okay, and then you can also STDEV dot S, and the whole thing should give you the same thing. Okay, I'm not going to repeat how you can derive from there because I hope that something you know. Okay, that's how you do the SD. Okay. Now the next two functions I want to cover is called, we know it, skewness and the kurtosis. Okay, skew and cur. Okay, skew will be just skew. It's very simple. And we have skew P and not skew. I have to skew P and not skew P. So we have skew P and normal skew. When I don't write P, actually it's the sample one. Okay, the sample one is just